Okay, guys, we're back for another segment of hyperbola functions. All right, remember yesterday we started with hyperbola functions, what we refer to as our rational functions. So we are going to be picking it up from there. So for those who are joining in, we'll be looking at hyperbola functions. We looked at hyperbola functions yesterday. The session that we did yesterday, I posted the video of the live session for hyperbola functions onto the YouTube channel. So you can always check out that session on hyperbola functions. There we were looking at the form of the hyperbola function. We're looking at the form as per the grade 10 syllabus and also the grade 11 syllabus. We looked at that function and we looked at what the role of the parameter a, what the role of a is in the standard form of the function, what the role of that form of the function, what the role of p in the standard form of the function is, what the role of q in the standard form of the function is. So what we're going to do today is we're going to look at how to, because we looked at all of those things, we looked at how to then sketch a hyperbola function where a is positive, where a is negative. We looked at how to write down the domain and the range. We looked at how to draw the, or at least how to actually find the equation of the axis of symmetry for a hyperbola function. So there's quite a number of things that we did yesterday, and I'd kindly advise that people go and check out that YouTube video that I did yesterday. I posted at the live session. It was also interactive near the end. I had one grade 11 learner that actually was on here, and we had a thrill of a time. So yeah, just all right. So let's get cracking. So today what we are going to actually look at, YouTube name, Maths is a Game. It's just like this thing here that you have here. Maths is a Game is basically it's the brand, it's the name, it's the way to go, it's the way we should feel when we do maths. Should not feel like maths is like this painful jaw taking away a painful experience, like taking out your teeth at the dentist. That's not the experience we should be having when we do mathematics. So anyways, guys, I'm gonna jump right straight into what we are going to do today. Please excuse me for the noise, the surround sound, but just focus intently and intensely on what I'll be doing today. So today what we're going to look at is how to determine the equation of a hyperbola function. Okay, how to determine the equation of a hyperbola function. Kind of reminds me of Ebola. These bola sort of like function, parabola, hyperbola, kind of remind me of that disease Ebola. There was a time in the country when we were experiencing some intense Ebola outbreaks and stuff. It was quite insane. But anyways, guys, so we're going to determine the equation of hyperbola. How do we go about determining the equation of a hyperbola? So we're going to look at some examples. Let's look at our first one. Our first example. So let us say we are given, here we have it. Here is the function, passes through 1 and 5 here in the first quadrant, and then in the other quadrant, this is what we have. And the arrows are there intact. We have y axis, we have the x axis. Okay, so how would we go about then finding the equation of the given hyperbolic function. So what we would do, obviously, guys, is that what we have, we need to first study what we have from the function. What we have from the function is that we have a function that is hyperbolic in nature, and the two arms are typically there. We have a horizontal asymptote whose equation is y is equal to 2, which makes sense because this horizontal asymptote is above the x-axis, so it should be positive because all y values above the x-axis are positive. Then what we notice is that the function is actually found, its arms are found in the first quadrant and in the third quadrant. By quadrant, guys, remember that the boundaries of the asymptotes will define for us the what? The boundaries of the quadrants. So this is then our first quadrant, because this horizontal asymptotes basically caps this boundary of the first quadrant to actually be defined in this region. Okay, then this is our second quadrant, this is our third quadrant, and then this is our fourth quadrant. Okay, so what we see is that this function is found in the first and the third quadrant, so that means that our a value will be definitely positive. So what we do is we write out the form of the function y is equal to a over x plus q. All right, we write down the form of the function. Now the thing is, what I can see is that this function has a vertical asymptote, which is x is equal to 0. How do I know that? But it's not labeled. I can see that because look at the function. The function does not exceed the boundary of the y-axis. Rather, it approaches the y-axis but does not touch it. Okay, and then what you notice here is that this is the horizontal asymptote and it is there, it's given as the equation. Okay, so I know that the form I'm going to be using is y is equal to a over x plus what? Plus 2. Okay, then in that function, what am I going to do? I'm going to use what information I have. And since the horizontal asymptote, I'm sorry about that, since the horizontal asymptote is given to me, it's y is equal to 2. That speaks to what? This speaks to my q value. And remember, my q value, it means that my q value for the function is actually equal to 2. So therefore, I'm going to write in the place of this q value positive 2, because I'm given the horizontal asymptote as being positive 2. Okay, then what point does my graph pass through? It passes through the point 1 and 5. So I'm going to use this 1 and 5. All right, remember this 1 represents my x value or my x coordinate of the point, and then this 5 represents my y value, my y coordinate of this particular point. This is a point that is found on the function. It's this point, it's 1 and 5. So therefore we go and substitute in the place of y, we substitute the value 5. In the place of x, we substitute the value 1. Okay, plus what? Plus 2. And then we solve, or we find the value of a through substituting the point and the horizontal asymptote, the value of the horizontal asymptote. So then here we're going to solve for a now. We have 5 is equal to, remember, a divided by 1, or a over 1 can be written as a plus 2. What we do is we transpose the positive 2 to become negative 2 on the left hand side. We isolate the a. 5 minus 2 is 3, therefore a is equal to 3. Was I expecting to have an a value that is positive? Oh, definitely. Why? Because my hyperbola function is located in the first and the third quadrant, which therefore speaks to the fact that my a value is definitely going to be positive. It would have been a sad outcome for me to have found that my a value is negative. That would have spoken to an error that I may have possibly made in my substitution and ultimately in my solving for the value of A. So what's very important here is to make sure, right, that one, if the horizontal asymptote is given there in my form of the hyperbola function, which is a over x plus 2, I substitute in the place of 2 my horizontal asymptote value, my q value, which is 2. There it is. And then I use my point substituted in the place 1 and 5, meaning the x coordinate of the point and the y coordinate of the point, which is 5. In the place of y, I substitute 5. In the place of x, I substitute 1. Then this gives me an opportunity now to see that, oh, my a value, I do not know what it is. It is my unknown, and I can solve for it. So let's go ahead and solve for it. Okay. If we were given the x, or in other words, if we were given the vertical asymptote, if the vertical asymptote was given to us, then my dear beloved friend, like here, we have been given the vertical asymptote. Okay. I may have well done this in actual fact, to be honest, because remember, this vertical asymptote was not explicitly written down, but it is something that I can actually conclude that it is given to me, given the sketch or the function itself, because I could see the horizontal asymptote that was explicitly given to me, meaning it was given to me directly, y is equal to 2. But my vertical asymptote, there was no equation of the vertical asymptote, but I could clearly see that my y-axis is a boundary line where this hyperbola does not touch. Therefore, this is my horizontal asymptote. So if we are speaking in light of the grade 11 syllabus, well, you could go ahead and write y is equal to a over x plus p plus 2. Then you say y is equal to, and let's substitute our asymptotes first. A over, remember, this x plus p, okay? If the horizontal asymptote, the vertical asymptote is 0, we can just say x plus 0. All right, because we are grade 11s and we know this form, we can go ahead and do that. Then plus 2, the plus 2 speaks to the horizontal asymptote, which equation is y is equal to 2. Okay, so there we have it. We just write y, the q value being 2. Then we use the point 1 and 5, and we go ahead and substitute a over 1 plus 0 plus 2, and then we go ahead and solve for the value of a, which is 5 is equal to a plus 2. We transpose the 2 again, 5 minus 2. Therefore, our a value is equal to 3, which is no different from what we have just done in the previous example, okay, where we basically used this form because we could see that this is a typical situation where the vertical asymptote is x is equal to 0. Katleho, all right, guys, can I just, in all love and good feelings, sometimes in the comment section, people just post things. Like, for instance, my dear friend here, Katleho, is like, when are you going to do grade 10 maths assignments? Guys, listen up. If you want something to be done, such as, let's say, for instance, help or assistance with an assignment, remember, guys, I am here to assist and aid you, but that aid and assistance, it comes, when people are able to really ask. Some of you, it's almost as if you have this sense of entitlement. When you put comments in the comment section, you just throw comments in the comment section, and it's almost as if like, when are you doing this? When are you doing that? When are you doing this? Rarely do I ever see people comment and say, sir, may you please, there's that element that is missing sometimes when people are commenting in the comment section. All right. And honestly, sometimes that does not give one the right sort of like heart to want to do anything, because if people are not asking with a good heart, or at least asking, with sort of like a this in a way that you yourself will be touched, like, oh, okay, wow, then sometimes you tend to be like, you don't know if there's any sort of like respect or care in the statements, or also in the asking. So please, guys, let's try and be, I don't know what the word is, but I hope you get the heart behind the statement that I'm giving here. So yes, and you have the opportunity to also inbox me if there are things that really and truly they are burning in your heart. Okay, so please, guys, do that. But like I said, at the moment I'm busy with hyperbola functions, and my intention is to actually continue and finish that for the grade 11s, because at the end of the day I started a segment last night on hyperbola functions for the grade 11th. Now I'm actually continuing that, and I'm hoping to actually finish the part 2 of the hyperbola functions. But yeah, remember, I am happy to help, I'm happy to assist, I'm happy to sort of like serve you guys. But also, you guys need to also be sensitive to the fact that, well, at the end of the day, this is a person, and he's doing this out of the goodness of his heart. So therefore, there's a way of being able to do things, and also that speaks to the kind of character that one possesses, and that matters a lot. It matters a lot. If I was AI, I'm sure I wouldn't have any problem. I would just sort of like regurgitate and produce, without even maybe even sharing my emotion. But it's just that you are dealing with a person at the end of the day here, who's really trying to assist as much as I can. Under the circumstances. So getting back to the problem. So finally, guys, after we get the A value, now we can write down the equation y is equal to, and here's the thing, y is equal to, in the place of a, now we have 3 over what? 3 over x. Remember, the vertical asymptote is x is equal to 0. So that means that function has not shifted. It still has retained its position of vertical asymptote being along the y-axis as per the grade 10 syllabus. But then the horizontal asymptote, okay, we could clearly see its y is equal to 2. So therefore, our hyperbola function, the equation is y is equal to 3 over x plus 2. So that is just nice, straightforward, not a problem. You see, very clear, to the point, no problemo. Okay, so equations, guys, this is how we can go about finding the equations. No matata, akuna matata, Timon and Pumbaa stuff, if you know what I mean. All right, let us try and discover some other beautiful problems. Let's see if we can discover some other. Now, I just wanna see if we can't. Sorry, guys. I'm sorry. This is me trying to page through. Okay, I just want to look at some papers here, past papers, nice papers, because I know people are sort of like on exam mode at the moment, and test mode, exam mode. People are, I can sense people are like practicing like crazy. So let's look at this. This is Western Cape exam type question here. September 2015, WCED would speak to Western Cape. So look at this. Given h of x is equal to 2 over x minus 2 plus 1. So now we are asked, give the equations of the asymptotes of h. Now I know my people here in the comment section are amazing. They will give me these things. Give the equations of the asymptotes of h for what? For 2 marks. Speak to me, people. I know you will give to me the equations of the asymptotes of h. What do my people have to say? My people are sleeping. I've got slippers here. I've got slippers. Yeah, you see? Look at this. These people. Yeah, I gotta love. Okay. Guys, you see the key word here is equations. If you are not writing your answer as equations, then these marks, you are going to say goodbye to them. I don't have any other words to say to people that don't write their answers accordingly. So if you're not writing your answers as equations, then say goodbye to the marks. So they're asking here explicitly, give the equations of the asymptotes of h. So I'm still waiting for my people 6.1 to tell me what are the equations of the asymptotes. And remember, when they say asymptotes, equations, it's plural, meaning it's not just one, but it's two. All right. So asymptote-wise, when we talk about asymptote, okay, when you're talking about asymptotes are what? Asymptotes are your boundary lines that have what function? Boundary lines where the function is not defined. The hyperbola function is not defined on those boundary lines. You won't find the hyperbola function being represented there on the asymptotes. Please, guys, very key there. Okay, very, very key. So therefore, I'm asking you now, give the equations of the asymptotes of h. All right. So let us answer that question. Remember that 2 over x minus 2 plus 1. 2 over x minus 2 plus 1. If they are asking us to give the equation of the asymptotes, what are the equations of the asymptotes? Okay, from the new denominator, we have this x minus 2, which speaks to our vertical asymptote. That x minus 2 speaks to our vertical asymptote. So if we want to find the equation of the vertical asymptote, then that x minus 2, we know that we can simply say x minus 2 is equal to 0. We transpose the value of 2. And we know that the equation of the vertical asymptote is simply what? X is equal to 2. So you can simply write the answer because we know the inverse of the constant value in that expression, the inverse of the constant, gives you the value of the vertical asymptote. Remember, when x is 2, in the denominator, 2 minus 2 will give us what? 0. And if we have 0 in the denominator, this function is what? Is not defined. Okay? So that is why we say that x is equal to 2 is the vertical asymptote of a hyperbolic function. So please, guys, whenever you are asked to write the vertical asymptote, consider the expression in the denominator for your function, all right, in this expression, and then the inverse of the constant term is the value of the vertical asymptote. So x is equal to 2 is our vertical asymptote. Then what about the horizontal asymptote? Our horizontal asymptote for this function, guys, is actually, we consider the constant term after the fraction. So here it's positive 1. So that constant term as it is, y is equal to 1. That is the equation of the horizontal asymptote. So these are the two equations, guys, that I expected you to write in the comment section. I expected someone to say x is equal to 2 and y is equal to 1. This is the VA, and remember, by VA I mean the vertical asymptote. Okay, the first letters V and A, and then this is my HA, the horizontal asymptote. Okay, so remember, what did I say? Vertical asymptote is always given by the inverse. The opposite number of -2 is +2. So x is equal to 2 is the equation of the vertical asymptote. You can take this expression, equate it to 0, solve for x. That is the equation of the vertical asymptote. The horizontal asymptote is the q value as it is. This constant term, that is a standalone term, as it is, y is equal to 1. That is the equation of the horizontal asymptote. Okay, I hope we are together there. Let's move to the next question. The next question says, determine, or determine, as some people say, the x and y intercepts of the graphs of H. Determine the x and y intercepts of the graphs of H. This is the function. We need to determine the x and the y intercepts of the graphs of H. How many marks? 3 marks. Remember, x-intercept. What do we mean by x-intercept? Y-intercept. What do we mean by y-intercepts? So x-intercept means where the graph cuts the x-axis. We know there, where the graph cuts the x-axis, we let y be equal to 0. That is the x-intercept, where the graph cuts the x-axis, or where the graph touches the x-axis. Okay, we let y be equal to 0. Then what about y-intercept? This is where the graph or the function cuts what? The y-axis. That's where we let x be equal to 0. Are you guys with me here? Hey, thank you for the heart me user 6591187323890. Really appreciate that, Terushag. Hey, Terusha, thank you. So where the graph cuts the x-axis, that's the x-intercept. Where the graph cuts the y-axis, that is the y-intercept. So if we want the x-intercept, we let y be equal to 0. Where we cut the x, where we have the y-intercept, we let x be equal to 0. So let's go to the function then and write it down. We know that was h of x is equal to 2 over x minus 2 plus 1. Yes, I do tuition. You can send me an inbox message and we can chat further. It is at a price, of course. H of x is equal to 2 over x minus 2 plus 1. All right, so we let y equal to 0. Remember, this h of x, whether this is h of x, f of x, p of x, l of x, t of x, n of x, d of x, m of x, any letter of the alphabet, x, whatever. This notation is what we call functional notation. What does it mean? This simply means y. Yes, all grades, my leader, grade 8, 9, 10, 11, 12. This means y, right? So that's why we can say y is equal to 2 over x minus 2 plus 1. When we want to work with it, we can definitely do that. Now, to let y be equal to 0 means in the place of y, which is h of x, we substitute what? 0 is equal to 2 over x minus 2 plus 1. And I loved what my beautiful friend said yesterday, Luandle. There was a grade 11 learner who was here, who was really assisting me here when I was starting out with hyperbola functions. I had 7 people in the live, had a very fruitful lesson, and Luandle was my guest, and we were just having a big chat on these functions, and he was really very helpful. So what then we have here is 0 is equal to 2 over x minus 2 plus 1. We want to solve now for what? For x. So Luandle, what he did, or what he said, and I really loved his recommendation, is that he said, sir, let's transpose the constant term here. So positive 1, we transpose it to the left-hand side. Then we isolate the fraction. And then he said, let's cross multiply the x minus 2. And this is what happens, guys. We now have negative 1. If we cross multiply the x minus 2, we get x minus 2, which needs to be multiplied with negative 1. Then say we distribute. Hey, I love this. Negative 1, you distribute it to the x, you distribute it to the negative 2. Then we get negative x plus 2, say, which is equal to 2. Then negative x is equal to this 2 you transpose to the other side, which gives you 2 minus 2. And then the grand finale, negative x is equal to 0. Therefore, x is equal to 0, because you divide both sides here by negative, the coefficient of x, which is negative 1. But guys, we know that division by 0, if 0 is divided by a number, it just leaves 0. So x is equal to 0. This here, guys, is our x value when we let y be equal to 0. So what is this then saying to us, guys? In simple terms. In simple terms, all right? In simple terms, it's saying that we have an x-intercept and a y-intercept that is actually 0, 0, which is very, very, very interesting. X-intercept and the y-intercept, that is 0. So let's just relook at this so that we are sure that what we did is 100%. Remember, what we had as the equation was 2 over x, y is equal to 2 over x minus 2 plus 1. We truly did transpose the 1. It became negative 1, which is correct. We then cross-multiplied the x minus 2, which is the same thing, guys, as like saying, what is the LCD? It's x minus 2. What is the restriction? X cannot be 2. Remember, x cannot be 2, all right? Yeah. We first write the LCD, x cannot be 2. Then we take the LCD, we multiply by the LCD for both the left and the right-hand side. So when we do that on the left, negative 1 gets multiplied to x minus 2. When we multiply that LCD, x minus 2 on the right, the x minus 2 and the x minus 2, they cancel. We are left with positive 2 alone. So you see, guys, what basically we are alluding to. Then we distribute the negative sign. Negative 1 times x, negative x. Negative 1 times negative 2, positive 2. Transpose the 2, we get 2 minus 2, so negative x is equal to 0. There we have it. So when when y is equal to 0, x is equal to 0. What are we then expecting when we find the y-intercept? All right. Already from this answer, we can see what will be the result. But you know what? Let's just entertain the masses. Let x be equal to 0 for this function. So we just say h of 0 is equal to 2 over 0 minus 2 plus 1. Then we get 2 over negative 2 plus 1. We divide the 2 and the negative 2. A positive divided by a negative gives us a negative. 2 divided by 2 is 1. What's negative 1 plus 1? It's 0. So that means h of 0 gives us 0. So once again, we can see whether, guys, we are talking about the x-intercept or the y-intercept. Hey, it seems like the x and the y-intercepts of the graphs of h give us 0. Right? So the x-intercept, all right, of the function, okay, is x is equal to 0. The y-intercept of the function is y is equal to 0 as well. Okay, yeah. So just as we relook at what I've just done, if we go back, okay, remember I said here, I want the x-intercept of this function. What is the x-intercept? The x-intercept, guys, okay, the x-intercept is simply where the graph cuts the x-axis. So there, where the graph cuts the x-axis, what do we know? We know that there y is equal to what? To 0. So what we do is we take y is equal to 0 and go and substitute it in the function that we've been given. Remember, h of x, this kind of notation is called functional notation. H of x means y. Y means h of x. Why do they use h of x? Because it's just a unique way to distinguish this hyperbola function we are speaking about. So h of x, f of x, L of x, T of x, any other letter of the alphabet of x means y. So you then have to write the equation y is equal to 2 over x minus 2 plus 1. And then what do you want to now do? Find the x-intercept. So what do? You let y be equal to 0, which means in the place of y, you are going to substitute what? 0. There the 0 is. Then solve for x, because this is the only variable you have to solve for. When you do that, you take this positive 1, transpose it to the left. The plus 1 as a constant term goes to the left. It turns or changes to negative 1. When we transpose a term, the sign of that particular term changes, right? Then we are left with 2 over x minus 2 is equal to negative 1. We then cross multiply x minus 2, which is the same thing as finding the LCD, multiplying by the LCD left and right, the LCD cancelling x minus 2, so we are left with 2, and then the x minus 2 being multiplied with negative 1 into x minus 2. We take the negative 1. Since x minus 2 is in brackets, we distribute the negative 1 to the first term, which gives us negative x, because negative times a positive is negative, 1 times x is x. Negative times a negative 2, negative times a negative 2 gives us a positive, 1 times 2 gives us 2. Then we solve for the x value. Take the 2, transpose it to the other side. 2 minus 2 on the left hand side, on the right hand side, 2 minus 2 is 0. We have negative x is equal to 0. And then we divide both sides by the negative 1, which ultimately does that what when we divide by negative 1. When we divide by negative 1 on the left, we get a positive x, which is what we want. And then when we divide 0 by negative 1 on the right, 0 divided by negative 1 will obviously give us 0. So this here, guys, is what we call the x-intercept. It's x is equal to 0, guys. That's the x-intercept of this function. We are directly answering the question of determine the x and y intercepts of the graph. So the x-intercept, there it is x is equal to 0. If you had ended here, that would have answered the question for what the x-intercept is. All right, what we just did furthermore here is to write down the coordinates of the x-intercept. They did not ask for that, but remember, had the question asked specifically for the coordinates of the x-intercept, then we would have done that and written when y is equal to 0, which is in the y place, we write 0, then our x value is equal to 0. Then we move on. Now we want to find the y-intercept. What is the y-intercept? It's where the graph cuts the y-axis. There we let what? We let x be equal to 0 on the y-axis. Everywhere along the y-axis, x is equal to what? To 0. So we go ahead and we substitute in the place of x. We substitute 0 in the place of x. Then we solve. What are we solving for? For y, because we want the what? The y-intercept. 0 minus 2 is negative 2 in the denominator. we divide 2 and negative 2. What is 2 divided by negative 2? Positive divided by negative is negative. 2 divided by 2 is 1. Negative 1 plus that 1 gives us 0. That means our y-intercept, there it is, y is equal to 0. All right. Had they asked for the coordinates of the y-intercept, then we would have easily been able to say when x is 0, y, the outcome, is also 0. They did not ask for the coordinates. So ending here, where we say y is equal to 0 is enough because they wanted the what? The y-intercepts of the graph. 3 marks. 3 marks, guys. 3 marks. Now let's move on to the next question. Okay, so I hope all of us understood that, how to determine the x and the y-intercepts of the graph. That's how we go about doing that. Okay, we had answered this question, 6.1. Give the equations of the asymptotes. Remember, we said that the horizontal asymptote is given by the constant standalone term. So we say that the equation of the horizontal asymptote is y is equal to 1. Y is equal to 1. That would be our horizontal asymptote, always given by the constant. But the equation is going to be y is equal to 1 because it's a horizontal line. All right? Then the other asymptote is the vertical asymptote. To identify it, we always look at the expression in the denominator when we have our standard form of the hyperbola function. And simply what we do is we take that expression, equate it to 0, solve for x. Here is what we call the equation. X is equal to 2 is the equation of the vertical asymptote. It's x is equal to 2. Okay, let's continue. The third question says, sketch the graph of h. All right, sketch the graph of h. So let's go and see how we can sketch the graph of h. Sketch the graph of h. Let's see who's this person. Sketch the graph of h. Is it Karando?
Yeah, evening, say.
What is happening, Karakara?
I'm good.
You good?
Yes.
Oh, nice, man. I'm happy for you that you're so good. Is there something that you want to say? Something you want to help me with? You want to help me with sketching the graph?
I need help.
You need help.
Yeah,
With what?
with the domain and range. And
Domain and range. We are getting there. We're going to get there just now. Can you just allow us to sketch the function?
okay.
All right. Okay. So guys, with the hyperbola function, there's a few things that we must make sure. You know, I spoke yesterday about the fact that we need to first have the plan sorted out before we sketch the function. So we look at a few things when we look at planning of sketching of the hyperbola function. In the numerator, we have the characteristic parameter, which we refer to as the A parameter. Our A parameter will tell us about the shape of the function and the position of the arms of the hyperbola. So 2 here is positive. So our A value is equal to 2. It's a positive value. So in my plan, when I have my horizontal asymptote here and my vertical asymptote here, I'm expecting my function to be found in the first and the third quadrant. I'm expecting this after I'm done sketching. So I already begin with the end in mind of what the outcome of my sketch will be, because I know When a is positive, my function is found in the in the first and the third quadrant. But if my a value was negative, meaning this top numerator value, if it was negative, guys, then I know that the function would have been found on the second and the fourth quadrant. I hope we are sihamba sonke. Salela, you cannot sala behind. So that is the first thing. The second thing that we need to take note of, after we know the position and the shape, then we need to then make sure that we know what the horizontal and the vertical asymptotes are. What are the equations of those two? Now we've already found those. All right, remember, what did we say is the vertical asymptote? We said it's x is equal to 2. All right, the inverse of the constant term in the denominator is always the equation of the vertical asymptote. Sorry, that's the vertical asymptote there. Then our horizontal asymptote, the constant term, the standalone constant term as it is, y is equal to 1. That is the equation of the horizontal asymptote. So let me just erase this because it might lead to confusion. This is vertical asymptote. This is horizontal asymptote. There is the equation. Those are the respective equations. Then 3, we need the x-intercept and the y-intercept. We've already found those, all right? And remember, when we calculated and we found the points, we found that 0, 0, in other words, the origin defines both the x-intercept and the y-intercept. So the rest will be additional points, meaning additional points that will help us to know and understand the shape of the function. We will look at those additional points or additional coordinates that can help us to be able to clearly define what the function of the hyperbola looks like. So with that information, we have relatively good enough information to sketch the function. So let's first sketch in our asymptotes so that we know the boundaries. All right. So x is equal to 2. Where is it located on our Cartesian plane? Okay, so we are on this side. X is equal to 2 is on this. No, it's not on this side. It's on this side. This is negative 2. That is 2. We have 0 there. So it's 1, 2, and so forth. But x is equal to 2. We can go ahead and sketch with our nice pencil, because sketching, we can use the pencil. That's the place where we can use a pencil. So x is equal to 2. That's the boundary line of x is equal to 2. Then you label it, please, guys. You sketch it in, you label it. All right. Broken lines, as you can see, because those are boundary lines. Then horizontal asymptote, y is equal to 1. So 1 is above the x-axis. So we go ahead, we sketch a horizontal line. You use your ruler, please. Don't be freestyling like you see me do, because my other hand is holding my glorious phone. Okay, so we have y is equal to 1. Then you can see now the quadrants, they are very clear. You see, very clear, the quadrants, because quadrant 1 is here. All right, quadrant 1 is here, quadrant 2 is there, quadrant 3, quadrant 4. From the shape, what am I expecting to see the functions in quadrant 1 and quadrant 3? All right, and remember, we said that the y and the x-intercept are located there. All right, I think we have a winning function there. So I'm expecting my arm to be here. snap. Okay, definitely lost viewers there, that's for sure. Sorry about that, guys. Especially Karanga. Yo, my goodness. Guys, that definitely stopped things there. So I'm very sorry about that. Very, very sorry. Very, very sorry. Very, very sorry. Especially to those who probably were following along nicely. Now I can see there's like a huge. There actually be, I don't know, yo, what a large exodus of people gone like that. All right, but anyways, okay, so guys, like I was saying here, you first, whenever you are about to sketch a hyperbola function, what's important here is to firstly write down your a value. All right, you write it down, that a value, and then you state a is equal to 2, a greater than 0. If it's greater than 0, you are expecting or anticipating that your hyperbola function will be found in the first and the third quadrant. That's very important in your plan. So you actually have a intended end in mind. As you are sketching, it's not like you are just going to sketch. You are sketching. All right, guys, I'm sorry. There's a lot of disturbances that are happening. Look at the hour in which these disturbances are happening. Hopefully Karanga can come back. I mean, can come through again, because I can imagine he probably lost. I think a lot of you actually lost hope in the live. You just kind of left, but yeah, hopefully you guys can actually see that I'm back on again. So anyways, a is equal to 2. All right, that is from the numerator value. So a is greater than 0. We're expecting to have the function in the first and the third quadrant. Remember, what defines the quadrants are the asymptotes, the vertical and the horizontal asymptote. So we're expecting our function to be in the first quadrant and the third quadrant. Then, what was the equation of the vertical asymptote? Remember, it was x is equal to 2. The inverse of this constant term gives us the equation of the vertical asymptote. So we write x is equal to, what is the value? If this is -2, then the value of the vertical asymptote is +2. Then the horizontal asymptote is the constant, this constant standalone term, this +1. Y is equal to 1 is the horizontal asymptote. Our x and our y-intercept, we were able to find the coordinates of the x and the y-intercept in the previous attempt. We found that the x and the y-intercept are both respectively equal to 0, meaning basically that the origin is the x. Then lastly, point number 4, we need to then establish some additional points or coordinates for the function so that we can see for each arm where the function actually exists. So I'm gonna come here, guys, and the first thing I do when I sketch a hyperbola function is I draw my horizontal and my vertical asymptote. So x is equal to 2. Where is it located on my Cartesian plane? It is located on this side of the x-axis, the positive side of the x-axis. So x is equal to 2 is a vertical line. When you did straight line functions, you should have learned that any vertical line is given by the equation x is equal to some constant. So that's why we have this vertical line which is a broken vertical line, which we refer to as the vertical asymptote. Please, guys, it's not a solid line, but it is a broken vertical line, the asymptote that is vertical. We then write the equation of it at the end, at the bottom. Then we sketch our horizontal asymptote, which has the equation y is equal to 1. We draw another horizontal broken line, and we use our ruler, guys. Please don't be like me and draw freehand. You place your ruler there, you draw your broken line, horizontal broken line, you write the equation. By virtue of sketching your horizontal and your vertical asymptote, you have marks. You have a mark that you attain from the sketching of those two important asymptotes. Then point number 2, your x and your y intercept. Normally, your x and your y intercept will give you 2 points. But in this situation, there is one common point which defines both the x-intercept and the y-intercept, and that is the origin, 0, 0. Very rare. So that means we are going to have to then sketch our function through this what? Through the origin. This arm here is the arm that is represented in the third quadrant. But now we need an arm in the first quadrant, but we have absolutely no points. So what we do then is we try and establish some points that we ourselves choose. So I, for instance, love referring to points immediately after the asymptote that is vertical. So for instance, after 2, we know that the function does not exist where x is equal to 2. But immediately after 2, my next natural number is 3. So I use usually those next few natural numbers. I go to my function, substitute in the place of x the value of 3. You can even quickly use your calculator and just get the answer, 2. So in the place of x, I substitute 3. What's 3 minus 2? Okay, so just for additional points. 3 minus 2, you don't have to write this down, but I'm just writing it down so that you guys can see where this all is coming from. So I choose an x value. Okay, so when x is equal to 3, I choose an x value. When x is equal to 3, for that function, I have 2. What's 3 minus 2? It's 1. What's 2 divided by 1? It's 2. Plus 1 gives me 3. So when x is equal to 3, y is equal to 3. Okay, does that make sense? So then the additional point that I can then utilize to then represent one of the points in this first quadrant is going to be my x value 3. When x is equal to 3, my corresponding y value is 3. So where am I locating this point? It's there for that quadrant. All right. So at least a point, guys, at least a point you should have for each arm. You can't just draw an arm free-handed without having a point at least. You know, even the examiners, when they mark you, you know, they check if these arms of yours, the first quadrant arm and the third quadrant arm, do they have at least 1 point? All right, so that's why I'm saying if you see from your x and your y intercept there is no point for the other arm, it is your responsibility to ensure that you at least then choose an x value for that required quadrant and then substitute that x value in your function so that you can check what is the corresponding y value. So here, when x is equal to 3, the corresponding y value is equal to 3. And remember, what I said to you is that you can use your calculator to quickly get those points. You don't necessarily have to write it down and then get your corresponding y value. I'm just doing that here so that you guys can see that there is a responsibility that I have to ensure that I have at least another point for that arm. Okay. So I don't know if you are hearing me there, Karando, like with the sketching of the function, but you need to at least have a point for each respective arm. Your x and your y intercept sometimes provide those for you, but when they don't, you need to make sure that you check, an immediate x value after the vertical asymptote, and then check another x value before the asymptote, if it be that there is no point for that particular arm. So now I have there a point, it's 3, 3, and at least what I can do now is I can use that point, you see, and sketch that arm, and then I mark that is 3, 3. There's a point there for that arm. You see that? So there is my sketch. Sorted. Hyperbola. It's got a bowler. Definitely Zinkle, Mos. As usual, we post on the YouTube channel after it's done. Hey, but I'm going to have to actually try and delete that long period of time when there was darkness, because I think it will discourage many people when they are watching the video. When they see that period of darkness, they'll be like, what happened there? Okay. All right. There we have it, guys. Simple sketch. All right. I know some people will insist on having 2 points for your respective arms. I love those people even more. Maybe they'll ask 4. What happens when we are substituting 4? Look at this. In the place of x, 4 minus 2, that will give you 2. What's 2 divided by 2? It's 1. What's 1 plus 1? It's 2. So your corresponding y value is 2 when x is equal to 4. So when x is equal to 4, y is equal to 2. So that means the other additional point here is actually 4 and 2. At least my shape becomes shapeful when I have those 2 points, because I can connect those 2 points. And it's a nice, smooth curve, good people. Nice, smooth curve. Then here I can maybe possibly think of a positive 1. Is it positive 1? Yes, it's positive 1. When I substitute positive 1, 1 minus 2 gives me negative 1. 2 divided by negative 1 gives me negative 2, and negative 2 plus 1. It's 1, right? Yeah. Negative 2, 1 minus 2 gives me negative 1. 2 divided by negative 1 is negative 2. Negative 2 plus 1 is negative 1. So when x is 1, y is negative 1. So this additional point here is 1 and negative 1 there in that point. You see, then the connection is nice there. You can see the curve. It's curving very nice. So if you have the 2 points for each arm, no one can dispute how you have drawn the curve of your 2 respective arms. So I am just saying all of these things because it helps us when we sketch our hyperbola. Then we label the hyperbola. Remember, the function that was given, we said is h of x is equal to 2 over x minus 2 plus 1. So the points labeled, horizontal asymptote and the vertical asymptote labeled. The additional points that we include, we make sure that we actually provide the coordinates for those points, so that whoever is checking my function, they can see, hey, this guy knows his stuff, and the hyperbola function is on point. Okay. Then the next question that they ask is, give the what? The domain of the what? Of h. Now, what is domain? Maybe that's where I can call on Karando to come on. Karando, what is domain? All right, I actually spoke on this in my the first video I did on hyperbola. I spoke about the domain and what it is. But let's check if Karando, you are with us. Domain. What is domain?
Check.
And then we can follow it up with what is range. So let's start with domain. Activist today in the comment section says X values. X values. Activist. I wonder what manner of activist is activist. Yes.
The domain is how far can graph go horizontal?
How far the graph can go?
How long the graph can move horizontal left or right?
how far the graph can move horizontally, left to right. Okay, I love that. It's an interesting way of putting it. How far the graph can move horizontal, left to. I've never heard it quite that way, but I love that way of actually explaining it. Okay. So domain means x values, and these x values, it's where your function is defined. In other words, where your function exists. Where does your function exist? As you've said, left to right. Where does your function exist? Left to right. What x values show your function existing or being there from left to right? How far from left to right does your function go? I love that. Okay. I think all in all, we are just talking about the x values where our function will exist. Where does the function exist from left to right? That is the question. Okay. And the answer to that question is what we call the domain. Where does the function exist from left to right? Okay. So if I move this pen from this side, the left side, so we are coming from negative infinity, in other words, the function is going, it's going. I mean, the pen is going. And you can see that I can see that the function is there, it exists. By the function, I'm talking about my arm. Okay, so it means for all x values coming from negative infinity, the function is there. It's there. But tell me something, when I get to this broken line here, the x value is 2. Do I have the function existing on this line, Karando?
No.
No, right?
Yes.
Yeah. Then after that line, as I continue, do you see the function existing now after the line?
Yes.
Yes. And you see it existing all the way to what? To positive infinity. So the function will exist forever and ever. A hyperbola function, it's almost as if we can say a hyperbola function has no beginning. It has no end. But funny enough, it has a place where it does not exist. For a moment, there is a moment in life where that hyperbola function doesn't exist. You know, I don't want to be preaching here, but I would speak of other things to sort of emphasize the point, but maybe that will just be my opinion. So I will hold it right there. All right. But the function exists everywhere from left to right. So that is why, Karando, when we write down the domain for the hyperbola function, we say the following, especially if that hyperbola is actually, as you can see this arrow, it's an indication that this function will continue all the way, infinitely to the left. And this arrow is an indication that this function will continue infinitely to the right. Does that make sense?
Yes.
So for all x values, this function will exist. So to summarize the fact that the function exists everywhere, we use this notation. We say x is an element of real numbers. This simply means that the function will exist for every x value that you can imagine under the sun. Every x value, from left to right, negative all the way to positive. But there's only one exception. What is the exception?
But not.
Yeah, but not where? X cannot be what? Cannot be?
Equal to 0.
Okay, please take note. But x cannot be what? Do you remember what an asymptote is?
Oh,
Arando.
yeah.
So for this function, what is the asymptote? What is the equation of the asymptote?
2. Yeah.
Yeah, so x does not exist where the function does not exist where x is equal to 2. The function does not exist on this vertical line. Are you with me, Karando?
Yeah.
Yeah. So therefore we say when we write the domain, the function according to this, what we are saying here, x is an element of R. This is a short way of saying the function exists everywhere. The function exists everywhere. All right? Everywhere.
Yeah.
But, or except, what is the exception? This here means but. What is the exception? The exception is the vertical asymptote. Okay. Does that make sense?
Yes.
The exception is the vertical asymptote. In other words, x cannot be 2. Okay. Are you with me, Karan?
Yes.
All right. So that is very important for the what? For the domain. When you are telling me what is the domain of this function, first and foremost, you need to check where is the exception. The exception is always located on the vertical asymptote. You check what is the exception where the function does not exist. And obviously, I told you that that's this denominator. The x value that you substitute here, which will lead to the denominator being 0, is the exception, right? So we say here on this vertical asymptote, the function does not exist. Therefore, where, according to the domain, where does the function actually exist? The function exists everywhere. What does that mean? X is an element of real numbers. But what is the exception? X cannot be the equation of the vertical asymptote. X cannot be positive 2. So please, this is the manner in which we write the vertical asymptote. More especially if we know that the function is the type of function where it does indeed exist everywhere. You can see the arrow is an indication that it will go on this function infinitely without ever touching this horizontal asymptote on the negative side towards negative infinity. Also, this function will exist everywhere and it will continue onto the x value in the positive direction to positive infinity. Are you with me? So it will exist everywhere, but x cannot be what? Cannot be 2. Okay. I don't know if you have any questions, Karando, about domain of the hyperbola function. Any further questions on the domain? Are you clear about the domain now?
Yes.
All right. Let's move on to answer the next question. What is the range, Karando, of the function? The range.
How long graph can go vertical?
Sorry?
How long can graph go vertical?
Okay. All right. I also like that one, what you've just said. All right. But more formally, we say that it is the y values. Okay. So instead of the x values now, as you have said, if we are saying how far are we going vertically, we are looking at the y values because the y values are from the bottom to the top. From the bottom to the top. I don't know if you remember that song that used to say, started from the bottom, now we here, you know. For me, it's like I remember that song when we were thinking about range. Started from the bottom, now we here. It's like, you know, almost when you're saying you started from the bottom, it means you were down there below. You went up, you know. And if you say now you here, it means you are more higher than you were in the beginning. So we look at range. Like you said, how far can we go from the bottom to the top. Y values is what we are talking about. If we are talking about that, the Y values where the function is defined or where it exists, that is the range. Are you with me?
Yes.
The Y values where the function is defined or exists. All right. So we are looking, as you have said, from the bottom to the top. We are looking from the bottom to the top. How far bottom to top? So look at the function again. Now I'm moving from the bottom with my pen. Look at me, I'm going up, I'm going up. You can see the function exists. You see, the function exists everywhere because you see this arrow, it's going down. You see, function exists. It exists everywhere. Remember this arrow, just because I'm having my pen here. Remember, this arrow means this function is even where my pen is at the moment. You see? Yeah. So as we are moving from negative infinity, going up, function exists. At this line, which we call the horizontal asymptote, what happens to the function? Does it exist?
No.
No. So that is the exception. Are you with me?
Yes.
Then we go up. Hey, we continue. Exists. You see, exists everywhere, all the way up. You see, this arrow goes up all the way, my leader, all the way. So do you want to tell me then what is the range of the function? Do you want to write down the range? Tell me, what would I write down? Surely you have an idea. Remember, it's the Y values this time, not the X values. So what are we going to say?
Y is an element of real numbers, but not.
Y is an element of real numbers, 100% correct with the first part. And then the second part, what would we say? But what is the exception
But
to this
Y will
function?
not equal to 1.
Aye, you are Pakati inside, my leader. Aye, you are the man. You are the main guy. Aye, you are the main guy today. Aye, you are the main guy. Aye, you are the main guy. So yes, 100%. That is the range, my lead. What is the range? So for the domain, we are always looking at possible x values where the function is defined, where it exists, as you have said, from left to right. So you always check your function, doesn't matter what it is, whether your function is a straight line. Hey, whether your function is a straight line. If we ask you what is the domain of this function, it's a straight line. Is there a place where the straight line won't exist? If there's an arrow on either end and you can see there's a solid line, when I move from left to right, is the function existing from left to right? Everywhere. You see, it's existing everywhere, is it? From left to right? What does this arrow mean? It means it can go on forever and ever.
Yeah.
To the left. What does this arrow mean? It means it can go on forever on the right. So my question to you, from left to right, is the function existing everywhere for the straight line?
Yes.
Yes, it is. Is there an exception? Is there a place where it does not exist?
Aye.
No, there isn't. So what would you say is the domain of the straight line function? What will you say? Since the function exists everywhere from left to right, what will you say, my lead? What is the domain? Karando now is getting cold feet. You domain from left to right. You said the function exists everywhere. So what did we say it means when the function exists everywhere? It means we'll say the domain is x is an element of real numbers. Are you with me, Karando?
Yes. Yes.
Yeah, because from left to right, the function is existing everywhere. There's no restriction. There is no place where the function does not exist.
Okay.
Then, what about range? Range still means possible y values where the function exists. So we are starting from the bottom to the top. We are checking, is the function existing everywhere from the bottom to the top?
Aye.
Yes, it is. It's existing everywhere. This straight line, Karando, look at this. This straight line is a solid line. There is no place where we are saying, hi, there's no asymptotes, no asymptotes at all. But furthermore, from left to right, the function exists everywhere. From the bottom to the top, this function exists everywhere. Okay?
Yeah.
Yeah. So you can say here as well, the range is y is an element of real numbers. Now check what is something that someone is saying in the comment section. Nganyezi is saying or asking, what about negative infinity is to infinite? Now, yes, that's an alternative way. If you don't want to write x as an element of real numbers, you can say x is an element of negative infinity to what? To
Positive
positive.
infinite.
Even with this one, you can say y is an element of negative infinity to what? To positive infinity. This is called interval notation. This is just another way of writing the same thing. So x is an element of R can also be written as x is an element of negative infinity to positive infinity. You decide which way you feel is more attuned to you. These
Set
are both
builder.
correct. Sorry?
Set builder notation.
Set builder notation. Yeah, set builder notation is also fine. But like I said, this is shortcut. You just say x an element of real numbers. You've covered, you've accommodated everything there is to be accommodated. X is an element of R. Or you can write interval notation. It's really up to you. Yeah. All right. Yeah. So the sooner we can answer the question, the sooner we can leave it 100% correctly answered, the better it is for us. All right. Yeah. So I was just highlighting that. Maybe you can check here as well. You know, let's say we had a parabola. Here's another thing to consider for domain and range. There's a parabola here. Let's say the parabola is concave up. We have a parabola that's concave down. We have a parabola that's concave up. Now, obviously, the maximum point, let's say this here, our coordinates are 2 and 3. And let's say here the coordinates are 2 and negative 3. And I came to you, my good friend, and I asked you, okay, let's just say this is negative 3, and let's say that is 5. And then let's say this is 0 and 3, just for argument's sake, right? Then I came to you and I asked, what is the range of the function? Okay, so once again, you go to your definition, you're like, what is the range? What is range? Range is possible y values, where the what? Where the function exists, where it is defined, right? So my question is, remember with range, we say from the bottom to the top, okay? And then remember with a parabola, the way the turning point is, we refer to this as our maximum value or our top value. Okay. For a graph that is looking sad or concave down. So either way, you can say it's a sad graph, not happy. Or we can go to Mr. Smile, yes. Okay, but this turning point, we call this the minimum or the bottom value. Okay. So if we are speaking about range of this function, where is this function existing range-wise? So remember range, you said range is from how far from the bottom to the top? Okay. Yeah. So we're looking from bottom to the top. Where is this function existing? This function is existing. Look at these arrows. These arrows are both going what? Down. It means we are coming from the bottom to the top. My question is, where is the top? Okay. For range, we are looking at y values. That is the y value at the top. And what is at the bottom? Negative infinity. So we are coming from the bottom, which is negative infinity, all the way to what? The y value is 3. Okay. So if you were to write your answer in interval notation, you're going to say y is an element of open brackets, negative infinity to what? To 3.
3.
But then you would write square bracket,
Yeah.
not
Because 3
open.
is included.
Amen, Baba. Amen. I when you are the one, bruh. You're the one. I Karando, you. Hey, aren't you a maths slayer, my leader? You slay the maths. Don't you slay maths? Destroy maths. You do very well. You see these things most. Right? So yes, from negative infinity to what? To 3. Okay. Right. That would be the range. Okay. Now, some people would say, write it in a different way. Okay. Y, okay, is what? Less than or equal to 3. This would be an alternative way of writing the same answer. Y is less than or equal, because remember 3 is included, but the function exists below the value of 3. Okay. So Nkateko Shaz is asking, please explain the square bracket. Maybe Karango can help us out. All right. Let me not take away Karando's glory there. Karando, you said square brackets. Can you just explain to Nkateko Shaz there in the comment section? She's asking, please explain the square bracket. Why did we write a square bracket, Karando, instead of an open?
Oh, because 3 is included.
Okay. All right. So this function, look at it. As you sketch this function, it touches this point. So this is a point where the function actually exists. It is a point where the function exists. This y value that is 3, the function at the y value that is 3, it exists. It is there. All right. So it is included. This value of 3 is included in the function. So because this value, this y value, which is 3, is included in the function, when we write our interval where the function exists, we are coming from negative infinity, which is, we started from the bottom, which is negative infinity. Okay. We are coming from negative infinity. Where are we going as we are going up to the top? We are going to 3. But we don't just go to 3, we reach 3, and we actually arrive at 3. So therefore, we need to include 3. The square brackets mean including the value of 3 in the range. All right. So I hope, Nkate Goshas, you are good, you are sorted. We include the value of 3 there. All right. So negative infinity to 3. Or, like I said, we could write the range in this fashion. We say y is less than or equal to 3. Remember, this means below. Less than means below. Equal means on the function. Okay. Yeah. So y below the value of 3, but on the function at 3. Okay. So that's why we say we can write the answer as y is less than or equal to 3. Okay. You're very welcome, Gateko. You can see Mos Karando was the one that helped you out there because he was the one who was first to say We include, it means included. So that's why we write a square bracket. Okay, let's go to range. Let's come here. How would we write down the range of the function here, Karan? This function. Now we are smiling, my leader. We are no longer sad. We are smiling.
You're talking about the range.
Yeah.
X is an element.
The range. We're talking about range. So when we talk about range, we are looking at the y values. So from the bottom to the top. So what's happening here?
Y is an element.
Okay, let's listen to the Grandmaster Karando. Y is an element, yes.
Of real numbers.
Okay, you are saying y is an element of real numbers. I'm listening. Look at Farmang. Farmang, it takes 3 builders 16 hours to build a wall. How long does it take Landoga 8 builders to build the same wall? So this must be a typical grade 8 or grade 9 learner. Karando, let me give you a chance. Remember, from the bottom to the top. Fameng, you give me send me a message in the inbox, right? I'll attend to your question. It's a very nice question, by the way. Indirect and direct proportion. It's grade 8 and grade 9. Okay, Karando, Kaloku, remember my leader, we are looking at the function from the bottom to the top. At the bottom, we have -3. At the top, look at the arrows. They are going on forever. Where? Going where? They are going higher and higher. Are they stopping as they go higher and higher? Are they stopping? No, but we have a starting point, which is the minimum point. We are starting at what for the y value?
-3.
Well, so how can we say y is an element of R? What do we need to say?
Y is an element of -3 to positive infinite.
Hey, be careful, my leader. Yeah, I was like, hey, this guy, what is he doing to me now? Eh? In Karando, we trust, and this guy is coming here and saying other things. Okay, so y is an element of? Give me how will the brackets look like, Karando?
In the infinity, use curve.
Amen. In the infinity, we use this one because infinity is a concept that shows numbers go on forever and ever. It is not a number, Infinity is just something that shows us we're going on forever and ever and ever and ever and ever to the top, never stopping. Yes? And then this side.
Square.
Ameni, 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 ameni. Hi, Karando, you must be sure about this stuff all the time, Karando. In you we trust, my leader. In you we trust. Okay, that's range. Okay, so the other way in which you could write it, we could say y. Okay, the function is above this y value -3. So we could say y is greater than or equal to -3. That's another way of writing the range. Okay. Yeah. So if you don't write in interval notation, you could write it this way. Okay. But hey, let's avoid silly mistakes like saying y is an element of real numbers, and then we cost ourselves by saying such. Okay. The last question I want to ask to you, Kara, is to ask you what is the domain? So if we go back to the set face function, what would you say is the domain of the function? Does the function exist everywhere from left to right?
Yes.
Yes, right. So what would you say is the domain, my leader? You are speaking truths today. What is the domain then? What will you say is the domain?
Of the first graph.
Yes, the first graph. If it's a parabola function and you just said now, I asked you, does the function exist everywhere? And you said yes. So what does that mean? What do I write as the answer for a domain?
Of y or x.
Look, what is the domain, Karan? Domain means?
X.
We are forgetting. Domain means?
Yeah. X
X
values.
value. Yes, where the function is defined or exists from left to right. So
Right.
what's the domain of the parabola? You said the function will exist
Okay, but
everywhere from left
mm,
to right. So
X is less than or equal to 2.
x is less than or equal to 2. Okay, no. Remember this 2 here. If you are saying x is less than or equal to 2, remember the 2, if you're saying x is less than or equal to 2, it means you're saying the function only exists this side. This means x is less than or equal to 2 from here to there. So this is the x values. X less than or equal to 2 means this side only. That's not true.
Mm,
That's not true.
is greater.
Okay, if you're saying x is greater than 2, it means this side only, and that's not true.
Mm. So X is an element of
Yes?
2 into positive infinity.
Are you just guessing now, Karando?
Mm-mm.
Okay, remember I asked you the question, Karando. Does the function exist everywhere? What did you say?
Yes.
Remember, okay, listen to me. If you say that the function exists everywhere, from left to right. Remember, we are talking from left to right. Does the function exist everywhere? Yes, it does, right? It means that, you see this arrow? This function will continue forever and ever, and ever and ever, and ever and ever, and ever and ever. There's no end.
Yes.
So this function is existing all the way from where? From where? From where? From where? From where? From where? From the left, which is what? From negative infinity all the way to where? To positive infinity. So that means we can write the domain as x is an element of what? Of real numbers. Or if we don't want to write that way, we can say x is an element of negative infinity to positive infinity. Yeah. Because of these arrows, they show that the function from left to right exists everywhere. There's no restriction here. Okay? The function from left to right is not restricted. There are no restrictions on the function. Okay? It would be a different story if there were restrictions. You always sometimes need to check whether the function is it restricted or not. Because when a function is restricted, then you have to write the domain according to the restriction. But in this case, the arrows are there and it indicates that the function is unrestricted. Okay, from left to right. Come here this side so that I can let you go. I need to go myself after this. I'm going to ask you the last question. What about this one? Domain.
Domain is velos.
I'm going to ask you the question again. Remember, domain means possible x values where the
X
function
values,
exists.
yes.
Does the function exist everywhere from left to right?
Yes.
Yes. So what is the domain then? I agree with you, it does. It exists everywhere from left to right. The arrows, left, all the way, arrow, right. So it exists everywhere. So,
Negative infinity to positive infinity.
amen. You write x is an element, negative infinity to positive infinity. Okay. My leader, I think for tonight I am done with you. You have to now go and do exam papers, questions, so that you can internalize the concept. So what you've learned today is good, but now in order for your body to get behind the knowledge you've received, remember, knowledge, when it is acquired in the mind, has a very short shelf life, very short shelf life. It can only stay there for a limited period of time. The way in which you ensure that that knowledge does not leave you soon is to make sure you take that knowledge and go and get your body behind it and do something with the knowledge. You go and apply it practically by doing problems related to the concept that you have just covered, so that in doing, practicing, you can then internalize, solidify, and make permanent in your mind and your body the information that you have acquired. So that is the way you are able to get the maths inside. Then who knows, maybe Karando, maybe one day you will be having your own TikTok channel and you will be assisting others with mathematics. I'll tell you this one thing. Me, I was never always someone who could help and assist other people in maths. But today I can do that because there is a few things in mathematics that I know. I am not the master of maths. I'm going to be honest with you. I'm not. But there are a few things that I know that can assist others to be able to know for themselves as well. But it takes people that are special who go and apply the knowledge so that they can internalize for themselves. So I hope you can be one of those, Karando, as you take it forward and you can build your own personal maths confidence so that when you write papers, that are designed to test you, you can be in the position of saying, no, I have acquired knowledge, I understand, and therefore I can answer a variety of questions, whether it be questions I've been asked before or questions that I knew, because I am competent enough, because I have the conceptual knowledge, which is supported by my practical practicing of the mathematics as well, because I've internalized it. So, my leader, I wish you everything of the best, together with those beautiful, amazing people that have been here on the sidelines, who have been listening attentively and also participating in their own space. Thank you so much, my brother.
Yes.
Yeah, and everything of the best moving forward. All right. Yeah, that was Karando. Yeah. Beautiful meetings, beautiful setups, beautiful everything. All right, guys, I'm going to have to love and leave you. I'm shipping out as well. Enjoy the evening, the night, and all of its goodness. Kanyes, thank you so much. Fat Albert, it was good. Mr. Simplicity, hopefully you are simple enough. It was simple enough. Ghosty, Kevin Wyatt, we've got Rue, we've got Somse, we've got Stacy, we've got Jesse, we've got Liema Mabesho, Kanyezi, Sammy Lex, and Uzodwa Wabandu. Sorry, Zodwa 12. Ish. I think that just snuck in there. But yeah, thank you guys. It was good. It was real. It was snazzy. Semilex is like, when will we meet again? When we meet again, what do you want to meet about, Semilex? Me, I'm very, like I said, guys, it's not easy for me to always be meeting on a daily. So if some of you are going to depend on sessions like mine, me, I come on when I am able to come on. All right, but let's hope tomorrow in the evening, once again, I'll be able to have a session with you. But do not bet on it. Okay, do not bet on it. How many of you are in grade 11? Just can you indicate in the comment section how many of you are in grade 11 and how many of you are in grade 12? Those who have joined in. Let's see, grade 12 babies, grade 11 babies. If you can just indicate in the comment section. Okay, Karando is in grade 11. Nice. Ngateko Shaz is in 12. Stacy is in 12. Zodwa 12. I'm guessing Zodwa is in 12 as well, because people nowadays they write their names with the grade that they are in. Okay. All right. Well, guys, yeah, like I said, I can't promise anything. I see that there is a need or a cry for Euclidean geometry. Karando, I would really encourage you to go and check out the live sessions. I've had live sessions with grade 11s on Euclidean geometry. We've covered the section, the topic at a very great length and depth, covering the theorems together in conjunction with some problems that have to do with it. So check the live sessions that I've done in the YouTube channel that I have. You can find the link in my bio. Maths is a game. It's the live sessions. I upload them raw as you see them and unfold as we do them. So just check that out. And yeah, maybe definitely as exams approach and as paper 2 approaches to be written, you'll find me doing exam papers with questions on that. Yeah, but thank you guys. We'll see each other again, and it was good. Thank you.